Welcome to clickmyproject.com. We will discuss about the product for channel quantization using Constellation based codebook for multi-user MIMO OFDM. Next we will see the abstract for the product. In recent years, multiple in multiple output technology have become promising feature in wireless communication technology, so that the higher spectral efficiency or better quality of services can be provided. Several advanced wireless standards are draft support to 8x8 antenna to achieve the gigabits transmission rates that fulfill the requirement of video and entertainment applications. For example, new Android wireless LAN or Wi-Fi connections. The fourth generation mobile cellular standard or third generation standards are advanced WiMAX 2 connections using the MIMO FDM process. Hence, the evolution in spatial domain has prompted many researchers to devote themselves to algorithmic and actual architecture designs for higher order MIMO OFDM system. In this paper, we propose the cluster quantization technique for multi-user or orthogonal frequency division multiplexing technique using the Constellation based codebooks. The Constellation based codebooks provide the scalability and efficient code word search capability, which are keyword feature for the practical multi-user MIMO OFDM system with a large number of antennas. The proposed clustered quantization scheme quantizes the consecutive subcarriers into the single code word that minimizes the aggregator quantization error. We base our new clustering technique on two Constellation based quantization methods, namely equal magnitude and angular quantization or square lattice angular quantization. The new efficient codebook search algorithm are proposed for the cluster quantization. In addition, we proposed a new Constellation to crash different user quantization signal into the distinct code words. One is a rotated MBSK Constellation suitable for randomly distributed user scenarios, and the other is random phase equal magnitude Constellation suitable for ill-conditioned user scenarios. Thus, the full spatial multiplexing gained can be achieved even with small under user of. Finally, a new near spare code word search algorithm is proposed for the RPM. In simulation, the proposed cluster quantization shows up to the 50% of higher throughput compared to the conventional fixed palette channel quantization technique. Next, we will see the flow diagram for the product. First, we will get the input data for the input signal given to the process. Thus, the input data to be passes to the QAM modulation signal, then modulate the input data signal and go to the OFDM signals. Then the OFDM signal to be quantized the input data signal using the subcarrier of OFDM samples signals. Then go to the codebook generation. The codebook generation to be identify the clustering based concepts. The clustering based concept used to the subcarrier of the original signal transmission for the transmitter side. Then the codebook to be stored by the separator frequency for the every quantization signals. Then the channel efficient matrix values to be identified by the based on the channel state information window. The CSI window to be used to the analyze the characteristics of signal transmission and reception side. The characteristics to identify the path relay and path gains, and also various characteristics of the input signal characteristics in the codebook generated signals. Then the transmitter to be identify the number of transmitter and receivers to based on the MIMO concepts. The multiple input multiple output to identify the number of transmitter and receiver side. Then the QAM demodulation is the reverse process of the transmitter side. The demodulate the given receiver signal, and then the identify the receiving data for the QAM demodulation signal. Then calculate the SNR value and beta rate value for the received data, and to identify the analysis of the MIMO FDM performances for the energy efficiency in the MIMO OFDM codebook generation modules. The signal transmission up to transmit the transmitter to receiver side, the MIMO OFDM to be consumes the energy efficiency for the different codebook generation process and to reduce the energy efficiency level for the input signal based on the SNR and beta rate values, and finally to analyze the beta and SNR rate values in the receiving signal, and finally we will see the output for the product. First we will run the main, then run the first output window for channel quantization using consultation based codebook for multi-user MIMO OFDM signal. First load the input data signal, the input data signal to be plotted by the graph, then the transmitter the signal for the OFDM sample carrier signals, then the OFDM sample signals to be used to the quantize the input signal, then the analysis for the orthogonal transmitter signal for the various channels, then the transmitter signal for various carrier signal and the modulator transmitter signal, and the different subcarrier transmitter signal and signal placement for the signal consultation places. Then the next process go to the codebook generation. For the codebook length for the placed for 64, for the number of transmitter in receiver position to be 4. The codebook length 64 for the given data input points, and the receiver signal to be receive the OFDM signal for the channel process. The channel process to be receiving the receiver signal, then the demodulator signal for the given input data signal, then the demodulator receiver signal for the different subcarrier signals for the OFDM samples. Then go to the performance analysis graph for the channel quantization using the codebook for multi-user MIMO OFDM process. The performance analysis of the MIMO OFDM codebook generation. Now first we will see the SNR signal to noise ratio versus achievable throughput for Emac signal. Then plot the graph for the scalability of consultation based codebooks for the given enhancement process. Then go to the beta rate versus SNR ratio values to be displayed. Thus the beta rate graph to be displayed by the similarity graph for the beta rate versus SNR value. The beta rate value is to be plotted by the 0.46792 for the given first process of the beta rate values.